Is the deck of your boat starting to feel more like a soft sponge instead of a solid piece of wood? That soft, squishy, rotten feeling underfoot is enough to make any boater cringe. And now whether you're looking to buy a boat or this is your own pride and joy, the prospect of a waterlogged deck is no fun at all. It's actually very scary. But don't worry, we are going to test 4 methods to repair that spongy boat deck and bring it back to life. Stick around. If you're new here, my name is John and this boat is Antidote. Now, I am not a pro boat builder. I'm an engineer and a sailor with a dream of fixing up this old boat to go sail around the world someday, and we've got a lot of work to do first. If you've been watching the channel, you'll know that the deck of this boat is full of water and needs to get fixed, and I've been working on it in one of the ways that we're going to cover today, but there's been a lot of people in the comments that have offered different tips, tricks, and shortcuts to possibly get the work done a little easier, so let's take a look at some of those today. We're going to take a look at some of the more controversial methods of injecting different glues and epoxies into saturated cores. We're going to try and use vacuum to see if we can pull moisture out of the fiberglass core to make it more susceptible for gluing. And then finally, we'll simulate an entire deck rebuild by taking the fiberglass components and putting them back together with a water-resistant core material. We're going to test all these solutions for practicality and then put them to the test on the 20-ton shop press. We're going to see if these repairs actually work, or do they just add expense and weight to an already soggy deck. Now, these are the different samples that we'll be working with. And if you've been viewing the channel for a while, you might remember a couple of months ago, we took a field trip down to one of the local wrecking yards here in Washington State, and we actually cut these panels right out of the deck of a sailboat that's unfortunately going to the scrapyard, and they are completely saturated. So here's one of the samples here, and you can see there are areas where it is completely rotten, like coffee grounds. And then on the other side, it's actually got some areas where the wood is still looking pretty good. But I assure you, this is all soaking wet. This is probably a good time to give you a disclaimer that this is going to be a little bit of backyard engineering we have here today. So it's hard to know if these samples are coming from the same starting point. Obviously, the material inside is not completely uniform, so it's not really going to be apples to apples maybe, but we should be able to hopefully get some trends in the different samples and see kind of where things are going and maybe make some inferences on if these repairs will work for you in the real world or if they should be avoided. Now maybe you're wondering, why is it important to have a core on the deck of the boat anyways? Maybe I'll just get rid of that. Well, there is some good reasons for the core, and I did a video earlier that explains some of the different core materials that are available and why you might choose one over the other if you're doing a repair like I am, and that video is available up here. I recommend that you check that out. Now, why do we even care if there's water getting into the deck of the sailboat? There's a couple of good reasons. One is that, as you've noticed, most of the cores in these things are made out of wood, and wood rots. Unfortunately, water tends to get into the deck through different means, and it has a very hard time, almost impossible, getting back out. It can come through cracks in the gel coat if you've dropped something on the fiberglass and maybe compromised it. Maybe there's an old hole from a fitting that wasn't properly sealed on the inside and water's been dripping past that fitting, getting into the core of the boat. But rest assured, if you've got an old sailboat and it has holes in the deck, there's probably water in it and it is not coming out easily. Now maybe you've got a foam core and you're a little less concerned about water getting inside, but I would remind you that if you live in a climate like we do here in Northwest Washington, where you do get a freeze and thaw, anytime that water gets in and freezes, it's going to expand and it'll break some bonds in whatever it's lying next to, potentially. And then as the seasons continue, that's just going to keep creeping and breaking bonds as it goes, eventually compromising the deck. So no matter what kind of deck you have, you want to try and keep water out of it if you can. So let's talk about the fixes. Each of the test cases that we're going to go through has 4 samples to test. Half of them have been taken from the port side sample and the other half have been taken from the starboard side sample. You'll notice that all of the samples have some numbers written on them, and those are the high moisture readings in that area that I took from my Tramex Skipper moisture meter. Here's a quick rundown of the tests that you can expect to find in this video, and we're going to of course start with a baseline and we'll finish with a complete proper rebuild using high quality marine epoxy and a PVC foam. In the middle, we're going to do a couple of different things, some workarounds and quick tips that I've seen online just to see where everything is at. Now, quick disclaimer here. This is not going to be a how-to video, and I don't generally advocate for workarounds or cutting corners. If you watch my YouTube series about refitting this old sailboat Antidote next door, then you probably already understand that. So we're just going to test out a couple of these things that I commonly see online and in forums, let the data drive the discussion. Here we go. So the first thing to do here is to get our baseline. So we'll take these 4 pieces and we'll put them on the shop press to see how they do, because maybe you want to do nothing with the deck. And so we're going to take a look at what that will look like if you don't do anything and just leave the water in there. Taking a quick look here at the test rig that we'll be using, and we have a regular 20-ton hydraulic shop press. We've added a digital readout for the amount of force being applied through this load cell to the workpiece. We're measuring the deflection with a dial gauge at the bottom, and then the points of the bending are all fixed in place by the rig itself, and then these pieces of plywood just capture these angle iron sections so that everything is fair and tested in the same way. So with that, let's get started. All of these baseline panels are essentially failed before we've even begun here, and so they immediately start to deflect very heavily. So I only measured them up to 3/4 of an inch or 19 millimeters of total deflection. And if you are on a boat and you're getting that much deflection in your deck, you're probably having a really bad day. I'll speed up the footage here so it's not painfully slow to watch. Interestingly, this last test sample had a solid piece of balsa in it that was reasonably well structured. It was still pretty wet. You can see that as we were testing the piece, the deflection sort of took on an S-curve shape. And I actually heard some cracking here, and then the forces went way down and then started to come back up again. So putting all the data together for these first 4 baselines, we see here on this graph how the deflection versus the force is represented, and they're all pretty similar. That one outlier for the 4th piece was quite a bit stronger, and it did have that break and then recontinued testing. For interest's sake, I put on just an upper and lower skin together with no core and tested that along with the other baseline samples. And plotting that out on the curve, we actually see a really reasonable mirror to the ones that have the failed wet cores. So what that kind of tells me is that basically this rotten balsa is almost the same as not having any core material at all. Probably one of the more important mechanical properties of a core material is its ability to resist shear forces. And so that's the side-to-side sliding forces. And to kind of help represent that, on these 2 fiberglass pieces, I drew 2 lines on each side of the piece, and then when we flex it down, you can see how those lines that were right on top of each other have now moved side to side. So that kind of helps you understand how that core in the middle is helping to resist those sliding forces. So the first test that we're doing here is with these epoxy repairs. And what we've done is drilled holes in the top in a regular pattern. We used the same hole pattern for all the tests so that it's fair. And we've injected unthickened 5:1 marine epoxy into the holes, and it's been keeping pretty warm in the shop next door, so it did a good job of flowing and penetrating, reasonably so. I'll get to that in a second. A couple of things I noticed. For one, this is quite heavy now. This is almost added 40%, 30 to 40% of its weight in epoxy, so that's going to depend on how much water saturation and rot has taken place on your deck. If there's a lot of open air space, you're going to need a lot of epoxy to fill it. That's going to add a lot of weight and a lot of expense. It's going to probably result in a very solid feeling deck though. This does feel really solid, and it'll be interesting to see how it does on the test. One thing I noticed is that because the balsa rots in a rather unpredictable manner, there was one area here that you can see is still rather soft to the touch, even though it was right next to 2 injection ports or holes. And I didn't force it through, I just injected the epoxy until it wouldn't flow anymore, and nothing managed to get its way to this spot. So likely there would be holes on this side that would have filled that, but when you can't see the core, you don't really know where the epoxy is going. You're just sort of going with some blind faith. The last thing I'll say here is that I did leave these out in the shop for a couple of days after I cut that panel apart, and they were very, very wet, and I was worried about the epoxy bonding at all, and I let them kind of air dry for a day or two. And although there is still moisture in here, I probably gave them a bit more opportunity to dry up, so this might sort of overrepresent what you might find in the real world if you don't have your deck dried out very thoroughly. Let's give them a try. So we're at 20 thousandths of an inch displacement, and we're already at 100 pounds almost. Previously we were looking at like 12 to 20 max, so big improvement. Let's keep going. So there's 125 thousandths, 1/8 of an inch. Still doing pretty good. I'm starting to hear some cracking noises. It's interesting, the epoxy is actually holding up really well. The balsa is failing, and you can kind of see it sort of sectioning off into little blocks. Oh, and there's some water squeezing out here too. That's funny. The other 3 epoxy tests were similar, and all of them were dramatically stiffer than the baseline tests. The second sample began to separate at around 300 pounds of force and 3/16 of an inch of deflection, and then this happened. So it really failed there. This third piece is sort of failing in that area that I said was dry. Sure enough, it's letting go. The fourth sample picked up the most weight out of any of the samples, 33%. So it's got a lot of epoxy in there, and it must have bonded really well because, whew, that was pretty incredible. Well, that definitely failed. That got to 1,400 pounds, 350 thousandths of an inch, over a quarter of an inch, almost 3/8, a little over 3/8, I forget. So at that time, we actually ruptured the bottom skin, broke it in tension. Pretty incredible. Taking a look at the graph for the epoxy samples, we can see that the loads have gone way up. All of the samples were able to hold at least 250 pounds at 1/8 of an inch of deflection. 2 of the samples were more than double that, again at roughly 600 pounds. The pieces that took the most epoxy seemed to fare better than the others, but you gotta remember this is at the expense of weight above the waterline. Now I will say too, the epoxy did bond better than I was expecting, and that could be because I let things dry out a little bit longer. If I would have just injected them right away when there was still quite a bit of moisture in there, it might not have been the same result. So maybe it would be interesting to try again with a sample that is completely wet. I do have some lying around in the shop here, so let me know in the comments down below if that's something that you'd like to see in a future video. And if you're enjoying this sailboat destruction testing video, I hope you're finding it helpful, and I'd love it if you'd hit that like button for me. It really does help the algorithm show this video to more people, so I appreciate that very much. Well, that's pretty exciting to break something there. So we're gonna move on now to the next test panel, which is the same idea, except now we're using a polyurethane glue instead of the epoxy. And the idea here is that the polyurethane glue actually likes to have moisture for curing, so it's going to hopefully bond better to a wet core. It does foam. You don't have this solid brick of filler, you have a foam instead. Trouble is that this is not a closed cell foam, it's actually an open cell foam as this stuff activates, but it does an interesting job of working its way through the material and foaming and filling in. Does it work? Let's find out. You can hear it starting to crack, and I can see a little separation along the bottom. Again, it's that bonding layer between the skin and the substrate that's kind of hard to manage. The second test sample only handled about 270 pounds before it started to fail. So now please enjoy this ASMR experience while it continues to give way. Wasn't that pleasant? Now the third test sample was very uneventful and a little underwhelming. It only handled about 200 pounds before it started to fail. The fourth and final test of this round handled more load but failed severely at around 340 pounds. Adding these samples to the graph, and we do see that they start off substantially stronger than the baseline test. It is certainly an improvement, but nothing near what the epoxy samples were able to deliver. Also, there is less of a weight penalty with the polyurethane glue compared to the epoxy, and expense is also lower. Something to think about. The next thing we want to test is a few samples that have been dried using vacuum. So the science here is that by actually lowering the pressure down to a perfect vacuum, you can get water to boil at room temperature. So you can remove the water from the samples. Well, that's the theory. Is it practical on a boat application? That's going to be a lot harder, but I do know a few people that have managed to accomplish this by putting ports in along holes on the top of the deck and pulling the vacuum and watching the moisture decrease over several days. Temperature is going to be your friend here, so you're going to want warm days for that. Now I put a bunch of samples into this vacuum pot, and right away I was able to see water boiling off on the edges. As that started to slow down, we added a little bit of heat to keep it working. This test was actually able to reduce the moisture readings of these samples. You can see here the baseline is now a little bit reduced. We weren't able to get all the way down to like 15%, which you would want for a proper repair, but we're definitely going in the right direction, so we know that the theory works. Now I also have some proof here in that this is the oil that we've been changing out of the vacuum pump, and you can see there on the bottom there's about 12 ounces of just pure water. So that's definitely coming out of the mixture, out of the parts and into the air, getting sucked into the pump. Now I also put in this small test puck just as sort of a reference to see if it was drying out. And when you open it up, you see here that we're completely dry. This wood is bone dry. And now an original piece that was sitting in the shop here, still soaking wet, looks more like this. And you can see here it's still very wet. Put a finger in there. Yeah. So it seems to be a pretty big improvement, and I'm hoping now that these 4 samples are quite a bit drier inside. And now, thanks to the magic of editing, we've already set these up, 2 with epoxy injection and 2 with the polyurethane glue. So now let's see how they do on the press. While we're testing the vacuum dried epoxy repairs, it does seem like the failures are usually occurring in areas where there is less epoxy introduced into the substrate. And on the back of this one, there's been quite a severe failure of the lower skin. A lot of tension there again. Introducing these 2 to the graph, we see that they do perform on the higher end at the initial stage, but they do taper off a little earlier than the other ones, leading me to believe that maybe there's some just randomness here, and that's to be expected. When I mentioned that these substrates are very uneven, and so I don't expect to get really consistent results. So take with it what you will. Let's try the polyurethane. While we're running the tests here on the polyurethane, we notice that there again tends to be separation on the bond between the core and the skin, either the upper or the lower skin. That seems to be a common failure point. And again, it's hard to tell how this is comparing because some of these samples have quite a bit of balsa that appears to be rather intact, even though it is showing to be quite wet. Now, adding these to the graph, we see that these samples did both perform better than any of the original tests using the polyurethane in the original samples. It could be just a coincidence again. It's hard to say. Again, do with this data what you will. And for our final test, I'm very excited to try these ones that have been repaired with foam. Now, I've used Divinycell H100. This is the same foam that I'm using on the deck of Antidote. Now, H100 is a pretty dense foam. I think it's an 8-pound foam, and sometimes most smaller boats will use a lighter foam than that. This has been dried. All of the skins were sanded and scuffed up, and we've used Hawk epoxy here from Seahawk to put these back together. It's a 5-to-1 epoxy. Did a great job of gluing these up. So let's see how these work. Let's say hi to a couple of the new Patreon crew members that really help keep this channel humming along. If you're interested in some behind the scenes updates and ad-free videos, then you can check out the Patreon link in the description down below. The folks whose names are appearing on the screen now go the extra mile to keep this channel moving, and I couldn't do it without you. Thanks all so much. Back to the video. The lower skin is responsible for the failure here, but that's an impressive result at over 1,000 pounds and ½ an inch of displacement. All of the rebuilt H100 PVC foam samples present similar results. This result really shows us how effective the PVC core is at transferring those loads from the core to the fiberglass skins, which is really what it's designed for. Now, all of these panels have a thinner lower skin than an upper skin. That's just the way the boat was designed. It's quite common. Now, these are huge loads on pretty small panels, and something that the foam ones did really well that the other ones can't really claim is that they were able to withstand some deflection and then spring back. Even at this one that went over ½ an inch of deflection, was able to get back most of the way, not entirely. So this type of repair that we're looking at here isn't just stiff and strong, but it's also really tough. It's able to withstand a lot of impact and movement. The forces of these panels failing is very violent, and this one here actually ended up breaking my dial indicator, but thankfully we were able to use this digital caliper, kind of jerry-rig this back into the system, and we're back in business. I told you we'd be doing a little backyard engineering, right? Plotting these out, I see that they are all capable of carrying loads almost as high as the single epoxy test. As a group, the results are really consistent, and they're able to hold up to 1,000 pounds. There seems to be quite a bit of flex that's allowed on these parts before a permanent deformation, so this represents a really tough deck that's also going to be very strong. These are also the only test samples that ended up lighter than when we began. So what should you do with the deck of your boat now? Well, I don't really know. These are a really narrow set of tests, and as I mentioned earlier, it's hard to compare apples to apples because you're not really sure where your starting point is. Now, what I hope that you'll do is take a look at this video, digest the results, look at your situation, and make your own decisions. Think about what your needs are for the boat. Consider the extra weight and expense of adding different things into the deck. The ability to remove moisture, is that something that you're going to be able to do or likely not? These are all things that you should consider. Ultimately, anything that's done that doesn't involve taking a peek inside is a bit of an unknown. While I won't tell you what I think you should do with your boat, you should know that the only procedure that I plan to use on the restoration of Antidote is the back-breaking, blood and sweat-inducing labor of love of a complete reconstruction of the deck with new proper foam. I'm sure there are many other tests that we could have done here and different ways to look at these things, and maybe if you're out there watching, you want to put something in the comments. Let me know what you think we should do next time. I'm sure that the wrecking yard won't mind if we come and cut a few more panels out of those boats down the road. I'd like to clarify that Diab, the makers of Divinycell, did not sponsor this video or this project in general. I am using that product on the boat, however, and that's why I used it for this testing. I think the quality of the product, though, is evident from the results. Seahawk and Hawk Epoxy are sponsors of the channel, so thank you for the epoxy to make this project a possibility, and this video in particular. Any epoxy is designed to go into a clean and dry substrate. So all of these injection test methods are a definite abuse of the product and not an approved application. Now, it still did pretty well, so great job, Seahawk. If you're new here, we're usually working on the 46-foot project sailboat next door, and why not check out this playlist to see what we've been up to. And if you'd like to know more about the different core material options that are out there and available for your project, this video down here would be a great watch. And subscribe here for more of these videos. You know all the rest. See you next time. Starboard panel that I removed, and the other half will be from the port sample that I removed. I've done the sides backwards there. Let's try that again.